Topic 15, triangle inequality. We're going to order sides and angles of a triangle given angles and sides. We're going to determine whether we can actually form a triangle from 3 given side lengths. And we're also going to determine a range of values for a third unknown side if I'm given 2 sides to begin with. Okay, start off with shortest, longest, smallest, largest angle theorem, which is really an idea. If 3 angles of a triangle are not congruent, then the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. Well, what that means is if I know 3 angle measures, and there is a clear biggest, middle, and smallest angle, that means that the biggest side is going to be opposite my biggest angle. So if this is angle B, the side directly opposite this is side AC. That's going to be my biggest side. The middle angle of angle C is going to be the side opposite that. In this case, it's going to be AB is going to be my middle side. And lastly, if angle A is the smallest angle, the side opposite that, BC, is going to be the smallest side. It works the other way if I talk about if we have 3 sides of a triangle not congruent, then the largest angle is opposite the longest side, and the smallest angle is opposite the shortest side. So looking at that again, if I have a clear biggest, middle, and smallest angle in my triangle, side lengths of my triangle, if AC is the biggest side, then the angle opposite that, in this case angle B, is the biggest angle. The middle side of AB, the angle opposite that is angle C. And lastly, if BC is my smallest side, that means that angle A is in fact going to be my smallest angle. Let's take a look at what the problems would look like. Example 1, list the angles from smallest to largest. So I'm listing my angles from smallest to largest here. While I'm given 3 side lengths, well, I know that if I rank my side lengths from smallest, middle, and large, the angle measures opposite them will also go smallest, middle, and large. So I see that 33 is my smallest side length. So that means the angle opposite that, angle H, is going to be my smallest angle measure. The next middle side length is 37. The angle opposite that is angle F. And then lastly, the biggest angle is going to be opposite the biggest side. 9 is my biggest side, so that means that angle G is going to be my biggest angle. Example 2, here we're looking at side lengths, and again we're going from smallest to largest. Well, I don't actually know the missing angle here by a simple triangle sum theorem. 66 plus 60 plus my unknown angle O is equal to 180 degrees. That means then that angle O is equal to 54 degrees. Okay, now in terms of listing my side lengths from smallest to largest, I know the smallest side is opposite the smallest angle. 54 here is the smallest angle, so that means that P is going to be my smallest side. The next biggest angle is 60. The side opposite that is going to be the middle side length, so that's angle. And that leaves my largest angle, 66. The largest side is O. Okay, these are great examples of SOL questions, SOL style questions, so we're going to see them as we review throughout the year and keep coming back to this topic. All right, last topic in this section is the triangle inequality theorem. It states that the sum of the lengths of any 2 sides of a triangle, the sum of the lengths of any 2 sides of a triangle is going to be greater than the length of the third side. So what that means is, regardless of which side I start with, if I take 2 sides of the triangle, it must always be greater than the leftover side. So in this case, if I took A plus B, it must be greater than side length C. If I took A and C and add them together, it must be greater than side length B. And lastly, if I took B and C, it must be greater than side length A. Okay. Now, in terms of determining whether a triangle is possible or not, we could set up all 3 of these inequalities, and we're going to see that in the next example that I'm going to set them all up. But really, what we really need to check is we must check the shorter 2 sides to the longest side. Okay, that's really the only inequality we need to check in order to determine whether there is a triangle or not. So let's take a look at practice 4. All 3 problems have the same directions of can a triangle have the following side lengths? Okay, so using the triangle inequality theorem, it says that the sum of any 2 sides of a triangle must be greater than the third remaining side. So I'm going to go ahead and write all 3 of those inequalities. B plus C greater than A. So I'm going to arbitrarily just call this 16 side length A, 39 side length B, and 28 side length C, and then fill in my values. So 16 plus 39 must be greater than 28. 16 plus 28 must be greater than 39. And 39 plus 28 must be greater than 60. Adding these values together, we get 55 is greater than 28, 44 is greater than 39, and 67 is greater than 16. Okay, looking at all 3 of these, all of these check out, so that means then this is true. A triangle can be formed. Can form a triangle. All right, now, in terms of my process, I could set up all 3 of these inequalities each time, but really, I need to compare. I go back to the notes on the bottom. I really need to compare the shorter 2 sides to the longest side. So coming back up here, the shortest 2 sides in this example were actually 16 and 28. So this is really the only inequality that I needed to set up and check, and in fact, it is true. Okay. From a visual standpoint of this, what we're looking to try to do is, if I see the biggest number, in this case, say it's 39, really what I'm testing is whether or not if I took the other 2 shorter lengths, so in this case, actually make this one 16 and this one 28. If I pin them onto either side of my longer side, if I took those 2 shorter sides and put them on the ends of the longest side, could I maneuver them in some way so that way they touch and they actually make a triangle? Okay. What we really don't want to have happen is the following. So if I have some long side, we don't want to have the 2 sides be too short. So these 2 little red segments that I have on the end, there's no way they're ever going to touch and make a triangle. So if the length of this plus the length of this can't be equal to my third side, because then we just have a straight line, it would look like this. If I had the red side right on top of the other one, I would just have a straight line. So this is if A plus B equaled C. This is when A plus B is less than C. What we need to have happen is these 2 side lengths need to be bigger, so that way there's a little bit of a gap, even just the smallest gap, just like this. So that way we can actually create a triangle. This is when A plus B is greater than C. Okay, that's why we really only need to check this highlighted green inequality to verify what's going on. We can check all 3 of them, that's not a problem, but this is really the one we're looking for. Okay, let's try. With that knowledge, let's go ahead and try examples B and C. I'm going to go ahead and label this is A, this is B, and this is C. Smallest, middle, large. On this one, I'm going to do the same thing, smallest, middle, and large. So in terms of determining whether this is a triangle, I need to test whether A plus B is greater than C. The sum of the 2 smaller sides is greater than the largest. Same thing here. A plus B is greater than C. So 18 plus 19 must be greater than 40. And over here, 33 plus 37 must be greater than 66. In B, we have 37 greater than 40. And in C, we have 70 greater than 66. In example B, this is a false statement. So therefore, we cannot no triangle. Versus here, this is in fact a true statement, so that means we can form a triangle. Form a triangle. So once again, visually on B, what happened is I have a side length of 40, and then my other two sides of 18 and 19, they get really close to touching and actually connecting, but there's no way they're ever going to, so I have a gap, which means we can't actually have a triangle, and that's what we showed with our inequality. Okay. This is another SOL type of question. This is another SOL style of question. The last two practices here are the other type of big SOL question that shows up on this topic, and that involves us finding a range of a possible third side. Okay, so in practice 5, a triangle has sides that measure 11 centimeters and 16 centimeters. What are the possible lengths of the third side? Write your answers in inequality. This is where we're looking for a range of values. Okay, so the sides of the triangle that we know are 11, 16, and our unknown side x. So I'm going to go ahead and set up all three of those inequalities again. A plus b must be greater than c. A plus c must be greater than b. And lastly, b plus c must be greater than b. And again, I'm just going to go ahead and arbitrarily go 11a, will be b, and my unknown sides x will be c. Plugging those values in, we get 11 plus 16 must be greater than x. 11 plus x must be greater than 16, and 16 plus x must be greater than 11. Now these are all one-step inequalities that we can actually go ahead and simplify. This simplifies to 27 must be greater than x, or x is less than 27. This one I subtract the 11 over, we get x is greater than 5. And here when I subtract the 16 over, I get x is greater than negative 5. Now, looking at these answers, x is greater than negative 5, that obviously has to happen as x needs to be a side length. So I can really throw this result out, leaving me with two inequalities, x is greater than 5 and x is less than 27. I'm going to write this as a combined compound inequality. So x must be greater than 5, but it also must be less than 27 for my range of values. Now, just like in the previous example, we set up all three inequalities each time. We don't necessarily need to do that. Really what we're looking for in each of these cases is, here I'm looking at whether x is actually the biggest side in the triangle, and here I'm looking at whether the biggest number I'm initially given, in this case 16, is the biggest side of the triangle. So here is kind of the shorter version of this. We need to have a lower bound, and we need to have a high bound with x in the middle. The way we get our high bound and the way we get our low bound is as follows. For the low bound, we're going to subtract the values that we're given, and for the high bound, we're going to add the values we're given. So when I'm subtracting the values, I'm assuming that the biggest value given, so in this case 50, is in fact the largest side. So I would do 50 minus 20, which gives me a value of 30, would be my low bound. And for the higher bound, what I'm doing is I'm assuming that the unknown side, x, is actually the biggest side. So I'm going to go ahead and add these together, 50 plus 20, which gives me an answer of 70. This again is kind of just taking the important pieces out of the triangle inequality that we had set up originally, where we set up all three inequalities. We're just kind of getting to the answer a little bit quicker. Notice again, we have our range of values. Again, this is an SOL question. We'll continue practicing this throughout the year, but there we go.